All right, we're back. We're on page 11 of notes 4. We're looking to finish this. So we're doing just random review problems based on the series test that we currently know. And so let's see if we can keep going. So here, when they're given, you have to like work out the nth term when you're given this and figure out what's happening. But this, every repeating decimal can be rewritten as a geometric series. Is that even true? I don't even know if that's true. I think that might be true. Repeating decimal. Yeah, that's got to be true. It has to repeat though. So what I'm going to do is I'm actually going to look at this as like 7/10, 7 over 100, 7 over 1,000, which I can then write as 7 times 1/10 plus, I'm going to do it the other way. I'm going to do 7 over 10 to the first. 7 over 10 to the first, 7 over 10 squared, 7 over 10 cubed, plus dot, 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 equals. All right, so I'm going to say this is equal to the sum from n equals, it could just go from 1 to infinity, because that's the easiest thing to do. So 1 to infinity of 7 over 10 to the n, which is definitely a convergent geometric series. So this is going to be, the first term is 7 over 10 over 1 minus the ratio, which is 1/10. So that's 7/10 over 9/10, which is 7/9, which I kind of knew going into it because 0.7 repeating is just 7/9, but still good to do it. So that's a convergent geometric. All right, this one. So the limit as n approaches infinity of the nth term is 0, which doesn't help me. But if it hadn't been 0, I'd be done, which is why it's worth kind of like thinking about it. So what does this look like? This looks like maybe you can't do it, but I think that if we can factor, we should. And maybe this is maybe this is telescoping. So let's do partial fractions. So we're going to have a over 2n plus 1 plus b over 2n minus 1 will be 1 over 2n plus 1, 2n minus 1. Okay, so if we'll let n equal negative 1/2, we'll know that a is negative 1/2. Which one am I covering? So I'm covering up this one. I get negative 1 over 2. And then if I let n equal positive 1/2, then b is going to be, so I'm covering up this one, I get 1 over 2. So when you write your summation, you want to rewrite it so it's like the positive thing minus, you want the minus in the middle, is basically what I'm saying. So I'm going to say that I'm doing the sum from 1 to infinity. Yeah, 0 seemed like there was going to be a problem, but you never know. 1 to infinity of, you actually just take out the 1/2. And then b is, so it's 1 over 2n minus 1 minus 1 over 2n plus 1. Okay, so these terms are actually 1 apart. It doesn't really, well, it does, no, they're 2 apart. So 2n, and then you plus 1 or minus 1, but it's really like n minus 1/2 and n plus 1/2, and take out another 1/2, get like 1/4, and then they're 1 apart. I think there's only gonna be 1 term left over. I don't know. I'm just gonna write them out. So let's see. 1/2. And then here we go. So we're gonna plug in 1, and we get 1 minus 1/3. And then we'll plug in 2, and we get 1/3 minus 1/5. And then we plug in 3, and we get 1/5 minus 1/7 plus dot dot dot. Okay, so definitely we can see what's happening. The only thing that's going to be left is 1. So it's going to be 1/2 times 1, which is 1/2. So it's nope, it's telescoping. And I think we found the sum, I hope. I'll check that on the calculator. Another telescoping, let's see. So we'll do a over 2n plus 5 plus b over 2n plus 3 is negative 2 over those two things, 2n plus 5, 2n plus 3. All right, so if we let n equal -5/2, then a is going to be, so we cover this up. Nope, we cover up the, you gotta like wait for it to disappear after you accidentally highlight. Covering this up, -5/2. -5 plus 3 is -2 over -2. Okay, so I think you just get 1. And then if you let n equal -3/2, so we cover up this, you get -3 plus 5 is 2, so you just get b is -1. All right, so we're doing, I'm going to take out the -2. Am I going to? No, I'm not taking out the -2. Did I mess that up last time? 1/2. I took out the 1/2. Nope, I didn't mess that up last time. I was about to mess it up. I was going to take out the -2, but then that would change my partial fractions, right? So don't take it out. Like once you've left it in, you got to leave it in. So this is going to be the sum from n equals 1 of, so 1 over 2n plus 5 minus 1 over 2n plus 3. Handwriting's going to not help me here. So let's do it. So if I plug in, how far apart do I think these are? I don't know. Well, 5/2 and 3/2. So I think they're 1 apart. I believe they are 1 apart. So I think there should be 1 term left over. So 1/7 minus 1/5. Plug in 2. 1/9 minus 1/7. Okay. Plug in 3. 1/11 minus 1/9. So what do we? I'm going to do one more because I'm pretty sure that just -1/5 is going to be the only thing left over. Yeah, I mean, it definitely is. But so 1, 2, 3. If you plug in 4, you get 1/13 minus 4, 8, 1/11 plus dot, dot, dot. Okay, so you can see the canceling here. So maybe 1/7, 1/7, and then 1/9, 1/9. But we skipped the -1/5. Like nothing's going to come back to get it. So it's going to be gone. So our final answer here is -1/5. All right. Let's see what else we got. Oh, nice. Okay, so nth term test of n over 2n plus 1 equals 1/2, which is definitely not 0. Since it's not 0, diverges. So therefore, the sum from 1 to infinity, n over 2n plus 1 diverges. Nice. That's the best. Here's another one. So this one, I don't know. It depends on the directions of the problem. Like we all, I guess, know that this limit is e. So that's not 0. Therefore, we can say this diverges. The question is, are you allowed to just say that this is e? I hope so. If not, you can do that natural log thing and like show some work. But whatever. It doesn't equal anything. It diverges. I guess I should say by nth term test. By nth term test. Can I steal that? Here we go. Watch. I'm gonna borrow this and bring it over here, and then make it look a little more like we meant to do that. Diverges by nth term test. Okay, so I'm gonna stop the video here. I'm not gonna stop the video here. I'm gonna check these partial fractions because who knows what could have happened there. But we're basically done, unless I got them wrong. We'll find out. So we could have just done the expansion. I'll use n, 4n squared minus 1 to get this. I'm gonna just check. I'm gonna like actually do the sum. So the sum from 1 to infinity of, I really just want to copy that, but it doesn't always work that well. 1/2. Yeah, that's what we got. Nice. Good job, us. Let's see if our expansion was right on the other one. So -2 over 2. 2. I wonder why that was already factored for us. That's probably me thinking like, I don't want to waste class time factoring. So we get this. All right, that's what we had. And then we want the summation from 1 to infinity of that thing, that answer. -1/5. Yes. All right, so we totally got them. So let's go back to the notes and then call it quits on this video and come back and finish the, well, maybe finish the note. Depends on what's on the next page. I don't actually know, but the next page is the last page of these notes. So we'll be very close to the end if we're not done. So I hope to see you there.